We've been getting a few requests lately for 532, 7018 out of position stuff, vertical and overhead. So tell us what we're doing today, Andrew.
We're going to be using the 532 7018. We're going to be running at the lower end of the amperage range. So there's going to be a couple points that we're going to talk about, a couple different techniques to employ in order to get a nice, flat, smooth transition and try to minimize undercut and a high throat.
I like it. We're going to be running 140 amps with 532 7018 uphill T-joint 3/8 inch thick metal. Now 140 amps is on the low end of the range for 532 7018. If we were using 1/8 rod, the range would be pretty wide. Like you could probably go as low as 100 and as high as maybe 135. And you could still do a good job. You still avoid undercut. You probably would still have a little arc blow toward the end of each rod. Here's a little schematic of the technique used here. It's an upside down V, and coming back on those sidewalls tends to fill in any undercut there might be, and then going forward just keeps your arc on the leading edge of that puddle, keeps you getting penetration into the root. All right, that's one rod down. Before we do the restart, let's take a quick look and see how Andrew's doing here. I don't see any undercut. Nice and uniform, slightly crowned but not excessively. Looking good. All right, our restart technique is to avoid any arc strikes. So Andrew's going to strike up ahead of the crater by about an inch, and you see it deposited some spatter and some stuff there, and he's just going to weld right back over it. That's the technique to avoid arc strikes. Make sure to weld back over any arc strikes that you do happen to have. It also lets the 7018 heat up just a little bit, and prevents porosity there on the tie-in. And you see that's the restart, the tie-in right in the middle there. Still looking good. The one benefit of using a large diameter 7018 uphill is you can go a long way. So if you were making a multi-pass fillet weld on some type of a piece of wide flange or some kind of structural steel, it's just more productive. Less restarts, more metal deposition, fewer passes sometimes. Okay, almost done with the first pass. Not really experiencing any arc blow, and part of that is because we do have the amperage set down toward the lower end of the range with the arc force set at about 50%, which is a little bit higher than recommended for 7018, but it's working out. Andrew likes to weld them all the way to the end and then wrap the corner. All right, it's paying down here. There's one restart. Here's another restart. And they're not very visible at all. Those are good restarts. So for the first half of the second pass here, we're going to do a weave pass. And in the second half of the T-joint, we'll do stringers. So one weave pass, and then on the second half, we'll stack two stringers in there. The weave pass is just basically what's called a Z-weave. Goes just something just about like this. Not spending much time across the middle, pausing briefly on the toes of the weld to fill in any undercut. That's the way of it. 140 amps still. Hadn't changed the amperage a bit. In fact, the amperage will just stay at 140 for this Z-weave pass here, as well as the stringers. And part of that is just temperature of the part. We didn't let it cool off much, just a few minutes to wire brush it and reset cameras and things like that. Temperature of the part does affect amperage by a little bit. Sometimes you can turn the amperage down a little bit if things getting really hot. Again, if you're starting off and it's cold, maybe you might need 5 more amps. Well, let's look at a restart here on the weave pass before we get into the stringers. Starting ahead by about an inch, then coming down into the crater, making sure to weld over all that stuff that was deposited on the cold start. Alright, then the same thing here, moving pretty quickly across the middle, pausing briefly on the toes to avoid undercut at a nice even rate. Alright, in just a second, when this is done, we're going to weld the second half with 2 more stringer beads. So we're going to stack 2 stringers over that first root, and the reason is because sometimes stringer beads are specified in a welding procedure. And if stringer beads are specified, then stringer beads is what you need to do, whether it's on a welding test or on production parts. There's a reason for it. You know, from an engineering standpoint, from a metallurgical standpoint, the theory is that stringer beads leave less residual stress, less overall heat input, and they have a tempering effect one after another that kind of helps with the properties of the metal after the fact. Quality-wise, as far as the quality of the weld itself, as far as whether you get penetration or whether you leave any, slag inclusions or things like that, that's a whole other story. Both methods definitely work. I mean, there's been a whole lot of welds done both ways, and they're satisfactory welds. It's just when in Rome, you have to do what's called for. So if stringers are called for, you do stringers. All right, last bead here. Andrew's watching carefully on the left side, not to leave undercut. Probably having just a little bit of arc blow right here. He's having to really manipulate the rod a little bit. He's going to weld all the way to the very end again and wrap that corner. A quick wire wheeling, and let's take a look at it. Let's pan down here. I know if I have my choice on a weld this size, I'd probably go with the weave if I was just given the choice. But again, you're not always given the choice, so it's good to be able to do both techniques. Both work. But when the procedure calls for stringers, you got to do stringers. Well, I hope this helps. This video is brought to you by my online store at weldmonger.com. See you next time.